Hi, today we are solving problem number 2742, painting the walls. We are given two zero-indexed integer arrays, cost and time of size n, representing the cost and time taken to paint and different walls respectively. There are two painters available. The first painter. So we have given two arrays, cost and time. And this cost array represents the cost taken by the paid painter to paint that particular wall. So we have n number of walls, and these are the costs taken by the painter to paint those walls. And this is the time taken by that paid painter to paint that particular wall. And we have one more painter, a free painter. He'll take 1 unit of time for all the walls. I mean, for any wall, he'll take 1 unit of time and he'll not charge anything. But the catch here is we can only use this free painter when this paid painter is already occupied painting some other wall. So if you see in this example, here let me clear. So here the minimum cost is given as 3, because if we ask the painter, the paid painter to paint the first one and the last one, or maybe let's take the second one. So while he's painting this, so the total cost will be taken is 3, since 1 plus 2 is 3. 1 plus 2 cost will be equal to 3. And in this time, while he's painting the first wall, so it'll take a 1 unit of time. So in this time, the free painter will paint this wall. And when he's at the second wall, he'll take 2 units of time. While he paints this, the free painter can paint this wall. Then it will become 3. One more possibility is the paid painter will paint this wall, and to paint this second index wall, he'll take 3 units of time, right? And at a cost of 3. So while this free painter is painting this wall in 3 units of time, we have 3 walls remaining. So we can get these 3 walls painted by the free painter in the same time. So by this way also, we will be spending 3 units of money. So that is the minimum that we can do. And let's take the second example. Here, the time taken is 1 for the painter, I mean for all the walls, and the cost is 2342. So in this case, I mean, since the time is 1, so we will obviously ask the painter to paint the wall which has the lowest cost, right? So while the painter is painting the second one, the free painter will paint this one, and while paid painter is painting the second one, the free painter will paint this one. So the total cost will be 2 plus 2, which is 4. So I hope the question is clear. Now, how can we do it? So, I mean, if you are thinking of any greedy solution like sorting the array and painting it, so since this depends a lot on the earlier state of the painters. I mean, if we are at, let's say, this value at 3, so to choose which painter to paint this, we need to depend on the earlier conditions, like which wall was painted, if whether that free painter is free or not, or can we choose this painter or not, all these conditions, right? So yeah, you might think some greedy solution might help here, but by sorting the array or taking some kind of heaps and all, but it would be complex that way. So the solution is, so I mean, let's try to do it recursively. let's say, what if this particular wall, the first wall, or maybe ith wall is painted by the paid painter. So there are two options, right? One will be this ith wall will be painted by the paid painter, or this will be painted by the free painter. Okay, so there are two conditions. So if this particular ith wall is, I mean, getting painted by the paid painter, so then what is the cost? Cost will be, I mean, what is the cost that we have till now? Cost plus this cost at that particular index, right? And so if let's say if that painter is painting some wall at ith index, and then how many total walls will be painted by that time? So if he is painting this wall, then he is painting that. So in that time, while this paid painter is painting that particular ith index wall, the free painter can take uh, the walls, the number of walls, I mean, the number of time that is, I mean, can buy the paid painter. Let's say to paint this ith index wall, if the paid painter is taking X amount of time, free painter will only take 1 unit of time for painting any wall. So he will paint X number of walls in this time, right? This free painter. So here, if this particular paid painter is painting the ith wall, then how many walls will be remaining? So this remaining walls will be remaining walls, what we have, minus 1 minus x, I mean, not x being the time, right? So units of time this paid painter will take to paint this, right? So yeah, this will be our I mean, yeah, intuition to solve this problem. So if we are at particular index, if this wall, I mean, needs to get painted by the uh, paid painter, then we will increase the cost and we will decrease the number of remaining walls to be painted by remaining -1 minus this particular time. 1 is because this wall is getting painted, and minus t of I is because in this time free painter will paint the walls. I mean, these number of walls, because he'll only take 1 unit of time painting any wall. So in the second case, if that particular wall is getting painted by the free painter, then what are we doing? So we are not hiring him, then the cost will not increase. So we just move on to the next one, right? So I mean, in that case, we will not take cost will not get increased. We will move to the next state, leaving this. So yeah, so let us take this recursive, clear this. So let me write this recursive function. So it will be at that particular index, would be cost of I plus mean paint walls of I plus 1. So and then we need to decrease the remaining. So remaining -1 minus time of I, or the next solution will be, we will not include that, so we no need to include this. Then the next one will be paint walls I plus 1, and then remaining. Since we are not taking this cost, so we need to do this. So we need to take the minimum of these two. This will be our recursive relation. So let's, so, I mean, we will memorize this instead of, by looking at this, we are sure that there will be some repetitions. So in order to, not repeat the flows, so we will memorize the solution that we have already calculated. That's it. So let me write the pseudocode for this. What we will do. Sorry. So, so we will create a helper function which will take uh, mm, the place the index that we are at, and the remaining walls that we need to take. So at first from here we will send this as 0, and the remaining walls will be the length of this, right? So in this helper function, what we will do, we will check for the base case. So the base case will be uh, if n is equal to length. I mean, if we have crossed the index, and before that, if this remaining is 0, then we need to return 0, because if there are no walls left, then it's fine. We have achieved the target, so we need to return 0. If we have not achieved, but we have crossed the length, then we need to return some maximum value, some integer max value. So this is the base case, and now we will calculate this solution. I mean, what if this gets painted by first one? So paint one will be equal to, we'll call this helper function with I plus 1 and remaining minus 1 minus cost time at that index, right? And also we need to add cost for this. And what is the solution? The second possible solution will be, we will not take that particular wall painted by this guy, paid painter. So then we will not include this cost, and it will be helper of I plus 1 comma, this remaining will still be the same. I mean, why we are not decrementing this remaining? Because we cannot decrement it, right? So we will only decrement, we are anyhow decrementing it here when we are taking the paid painter. So here we should not decrement this, because we are not sure if there is any corresponding paid painter that is painting the wall in on behalf of, while this free painter can be painted. So yeah, for that reason we should not decrement this. This will anyhow be calculated here when we are taking that particular painter. Then we will calculate the then only we will decrement the counter here. So yeah, so and after that we will return the min of paint 1 from paint 2, and we will also memorize before this, we'll also memorize the value for that particular index. if this particular walls are remaining, what is the solution? The solution will be this. And yeah, I mean, before calculating, we will also check that we'll do in the code. So let's try to code this. Let me initialize a cost array here. Cost and time. So I'm just initializing it here so that we don't need to send this cost and time in the recursive functions. This dot cost will be equal to cost. This dot time will be equal to time. And then we will call helper function with 0 comma cost dot length. So 0 being the total cost that we have achieved so far, and these many walls we have to fill. So let me just return this, and let us also initialize a memoization array. It's a 2D array. Then this dot mem will be equal to mu int of this length will be this cost dot length and cost dot length plus 1. Yeah, length plus 1 because we need to complete the time, right? And this is the number of walls, so we need to iterate through complete all the walls. So we need the nth index. So our answer will be present at the nth index. So yeah. So what is this helper function? So this will return an integer to paint from this particular index and these many particular walls. So it will take int index and int remaining. Let's say it's int remaining, right? If remaining is equal to 0, then we can return 0. I mean, we have achieved we have painted all the walls, so there is nothing left to paint. And if ind equal to n, then so without painting all the walls, we have crossed the index. So I mean, we are out of the painters before painting itself. Then let us return integer dot max value. So these are the base cases. So before going further, we will check if we have already calculated this value or not. So for this, if it is not equal to 0, then we have calculated this. We will return memorization of ind comma remain. Now the solution will be, the first case will be when we get that particular wall painted by the uh, paid painter, then the solution will be ind plus 1. Now we will move further, and the remaining will be remaining minus 1 minus time of ind. And the second case will be, we will call the helper function with id plus 1 and remaining will still remain same. And now we need to memorize this answer before returning. So memorize ind of remain will be equal to math dot min of case 1 comma case 2. But then we'll return the memorization of ind comma remain. So here we are returning, and for the base case, we are returning memoization of 0 and remaining. I mean, two from the starting index, if we are filling these remaining ones. So that's why here we are returning 0 comma cost dot length. So this should work. But one more thing, if here it is possible that this remaining might go to 0, then also it is fine. I mean, if that particular painter, if that particular paid painter is painting the wall, I mean, of cost 2, and if we have only one wall left, then this will be a 2 minus 1 minus 2, which is minus 1. So I mean, there is only one paint left for the free painter to paint. Then this remaining will be negative. So if it is negative also, we should return 0 only, because yeah, in some cases it is possible that the paid painter is painting and there is nothing left for the free painter to paint. So yeah, yes, this should work. Okay, so n being cost dot length. Not find symbol. Okay, my bad. It's just REM. It's just REM. REM. Okay, one last error. Variable I is not found because it is IND. Let me see where I'm. I guess it is failing because here we're returning the maximum value and here we are adding it. So it is going overflow. So instead of returning maximum value here, let's return 10 power 9. So now 10 power 9. Yeah. So, yes, that's it for this question, guys. Thank you for watching.